So data summary and display. So we'll talk a little bit more about diagrams, plotting. So we said you can take a sample of a population. So everybody is okay with the term population, what we mean with that. So this could be a population, a finite population, this class. And we could take a sample of that class or view, maybe 5 people, to get to know things about the whole class. Just because we're kind of frugal and lazy. So sample mean, so we can calculate the sample mean. I think that's quite obvious how we do that. So we sum all of the values. So if we're trying to measure the average weight of a person in the class, we could measure the weights and then divide by the size of the sample. So if you have 5 people, n would be 5. And so this gives us the average of that sample. So for a finite population, so for this class, of course, we could measure everybody's weight and then divide it by the total number of persons in the class, and this would give us the actual average of the weight of the person in the class. But the sample mean would then be an estimate, and we say it's a reasonable estimate of this population. And so we'll indicate the sample mean with its x bar and the population mean with its mu. Okay, so this will keep coming back over the slides. Okay, a second important thing we said last time already, and you know that statistics also deals with not just with the mean but also with the variance, and related to the variance, of course, standard deviation. So if we have these n observations, we can then calculate the variance of the sample by this equation. So this variance is a measure of how broadly the data points are distributed around the mean, okay? Because we're comparing the distance from a data point to the mean, the average of the sample, and squaring that so that we always get a positive contribution. And we divide by n minus 1, n being the size of the sample, n minus 1 because we basically took away 1 degree of freedom by calculating the average. Okay. So this is the sample standard deviation is then the square root of the variance, and it's the positive square root as is given. Okay, so this is how it's done. So we look at the average and then we look at the distances away from the average, square those and divide by n minus 1. Square those, sum them and divide by n minus 1. So you can calculate that. Obviously, most of your calculators have this. If you do it by hand, this is a kind of a neat formula to do it quickly. So you just sum the squares of the data points minus the sum of the data points squared divided by n divided by n minus 1. That's a fast way of calculating the variance. Okay, so for this particular situation we had there, this is calculated. The O-ring strength, which we looked at last time. So that's easy enough. I think all of you can do that. And then if we have a population which is finite, we can then also calculate the population variance, and this is then each of the data points in the population minus the mean of the population squared, summed and now divided by big N, because we didn't have to sacrifice a degree of freedom because we're not estimating here. This is for a finite population, so we can divide by big N. All right. The sample variance is once again a reasonable estimate of this population variance. So by doing a sample, we can estimate the mean of the population and we can estimate the variance of the population. So that's what we do. Of course, it's not absolutely exact, so we're making some error there, and we'll talk about that later.